And I'm Gaurav, and welcome back to Debatable Physics. So, for this episode's topic, I was thinking we could sort of link it with our last topic on simulation and talk about quantum computing. Specifically, whether it could do more harm than good. Now, the reason for picking this topic is I think there's a lot of uncertainty with regards to technology and how our day-to-day lives have changed. Certainly, it has been evident over the past 100 years or so, and even on a smaller scale, say the past 25 years with the globalization of the internet. I'm sure that people sort of pre-industrialization had absolutely no idea what was coming and how dramatically their lives would change. The same could be said for the invention of the World Wide Web. And once again, I believe we've reached another turning point in human history, and that is the invention of, and eventually mainstreaming of, quantum computing. Now, I have absolutely no clue how our lives will change. Most people only speculate, but what I do know is that it will change dramatically, and how it could potentially change, I think, would be an interesting thing to talk about today, both the good and bad. So I was wondering, where did you guys first hear about quantum computing?
It's difficult to say. It's probably because it's like it was in a documentary, but I don't know which one specifically. So it's one of those like quantum mechanics documentaries, and like they're like, oh, quantum mechanics this and that, and but I don't know. It might have been, maybe it was probably like either it was one of the famous scientists you see on TV. It's like either Brian Cox or Jim Al-Khalili, I think. I don't know. I don't know which one. It's just one of the main public speakers, like on in the science community. So
Yeah, I remember watching this documentary from the BBC Horizon series. That's sort of where I first heard and learnt about quantum computers when I was 13 or something. I don't know if you've heard of Horizon, but it's this really good documentary series that has been going on for a long, long time. And most topics they do happen to be about science and physics. And it was one of the main sort of catalysts in inspiring me to study for a physics degree. But as a 13-year-old, I remember having my mind blown about the potentials of quantum computing, even though I had absolutely no idea how quantum mechanics worked. And here I am, studying a physics degree, still not knowing how quantum mechanics works. But yeah, how did you come across quantum computing, Aysha?
Yeah, I guess I was in school probably when I first heard about it. It's not something that I fully grasped until I came to university and actually started learning more about both computers and about quantum mechanics and quantum physics. But I guess the more I learned about it, the more it seemed crazy to me that this was a thing and this was actually possible. Because when you learn about quantum mechanics, it's also abstract, and you kind of think that, I don't know, that you can't really see the direct link with how it applies to real life situations. So when you kind of hear of these examples of it actually being utilized and being used, it's kind of amazing to think that all of these really abstract concepts and ideas like scientists are able to use in daily situations.
I absolutely agree with you. I think science, particularly physics, gets a lot of hate for being too abstract for the general public. They sort of see physics as a discipline whose research will have absolutely no impact on their lives at all, and sort of the global governmental funding it receives is often criticised as people are like, the money would be better spent on eradicating poverty or whatnot. I mean, I'm sure there are a lot of people out there who think the Large Hadron Collider is a bunch of waste of money, and this is an issue up for an entirely separate discussion, possibly in another podcast that would need dedicating to this. But a lot of people don't realise that it can have a profound impact on our lives. For example, atomic physics will help us harness the power of hydrogen and nuclear fusion, and in our instance, how quantum physics will shape the future of computing.
Um, well, I think one of the main things is just, of course, the sort of just ability to compute, to like perform computations faster. That's one of the main things about quantum computing. Obviously, the ability to hold sort of multiple quantum states as opposed to classical states, which are limited to sort of holding one state. It obviously gives quantum computers a degree of superiority over their classical counterparts. So naturally, that's a thing that can be exploited, and if you can somehow make that more widespread, then that's naturally going to uh, help out in all walks of life.
So I think, first of all, for those of you who have no idea of quantum computing or don't understand it, like most physicists, because quantum physics, we're going to try and simplify it for you. Would you mind explaining the basics of quantum computing, please, Aisha?
Yeah, sure. So I guess to know about quantum computing, you kind of need to know how it's different from normal computing. So normal computers use these things called bits, which is an abbreviation of binary digits, and they're represented by either zeros or ones, and they're used to communicate information within the computer. I think most people would be more familiar with bytes, so like megabytes, gigabytes, like when you're looking at laptops or phones in terms of their storage. And these are just collections of bits grouped together. They're represented by either electrical or optical pulses. And what happens is they're controlled by these essentially gates called transistors, which either stop or allow the flow of electrons through them. But we're kind of approaching the physical limits that we have for how small these gates can get. So once we start to get much smaller than we already are, the electrons in the pulse can essentially just pass through the gate, whether it's open or not, through this process called quantum tunneling. Which renders the gate obsolete, really. So because we're approaching this sort of like realm where quantum phenomena are much more important, we can also exploit some of these phenomena as well, and that's basically what quantum computers do. So they use these things called qubits, which basically the same principle, but instead of having a pulse of electricity, it is represented by one subatomic particle, so it could just be one electron, and this electron can exploit quantum phenomena such as superposition, so it can be in a multitude of states rather than just being 0 or 1, and it only collapses down to one of those states when it's measured. The other phenomena that they utilize is a property called entanglement. So if you have a pair of entangled particles, if you alter the state of one of the pair, it also alters the state of the other in the pair. So you can measure one of the pair and you will directly know what state the other in the pair is. And the basic example of quantum computing versus classical computing is if you consider 4 bits in normal computing, there are 16 different combinations of zeros and ones that you can have those 4 bits in, and you can only pick one of those 16 to have those 4 bits represent. In quantum computing, if you use qubits, you can have those 4 qubits represent all 16 states simultaneously. And so you can see how it exponentially increases the power of the machine versus normal computing.
Thank you for that explanation, Aisha. Now, I'll link some YouTube videos and books in the description for people wanting to read more about the physics behind quantum computing as well. The main sort of big thing that could change, and I think quite a topical issue even today, is the privacy and protection of data. With the introduction of the GDPR in the EU, organisations that hold personal data have become more accountable now. For example, British Airways was the first company to have been fined under this new law for their data breach in 2018, which affected about 500,000 customers. Now, they were fined by the Information Commissioner's Office an eye-watering £183 million. So, never before have people and organisations now become more self-aware of what they're putting on the internet. Vulnerability to cybercrime, or just having their personal information becoming publicly available. So, why am I talking about all of this? Well, because either our data on the internet, our private lives, our messages, it will either become more protected or more at risk of being hacked because of quantum computing. So, would you please like to explain how, Alex?
Yes. When you say explain, it will be a very simplistic overview, but because I'm not fully aware of how these things work myself. But one of the main things at play is the fact that in classical encryption techniques, what you often do is you generate keys. You pick two prime numbers, and you use those as prime factors, and you multiply them together to generate the key. Now, in terms of intercepting this information, one would have to find these two prime factors. Now, what quantum computers can do is they're very, very quick at computing prime factors. So that is probably one of the main reasons why quantum computing is so potentially dangerous in this field of encryption, where you have the classical encryption techniques just not being able to fend off this new sort of superior quantum computing processing. So by that ability to process the prime factors of a key like much faster, the quantum computers pose a threat in that way.
I guess, yeah, so when you look at classical encryption techniques, the thing is that you can decrypt something using normal computers if you had like an infinite amount of time and an infinite amount of computing power, and that's just not something that's feasible, which is why they're thought to be so secure, and quantum computers are just kind of making that process a lot faster, which is why it's an issue now, because suddenly all of these old encryption techniques that we thought were totally secure are basically, you can like factorize really large semi-prime numbers quite quickly using quantum computers, and that wasn't really possible before.
So, when it comes to hacking, hackers usually play a guessing game. Whenever you send something over the internet, they basically try to guess the encryption key that was used to encrypt the information. And without going into too much detail, something called Shor's algorithm can be used to decrypt these keys. The algorithm finds the prime factors of any number it is given. Using traditional computers, this would take ages, but with a quantum computer, using Shor's algorithm to find out these encryption keys becomes feasible and a reality. And if hackers can do this, well, then they have the key to, say, all of the world's data. I think another major concern of quantum computing is really the race to creating cheaper quantum computers. There are a number of large organisations in the world, some regulated, some not. Basically, there is this race to quantum supremacy. The idea that a quantum computer will be able to solve a problem that no standard or even supercomputer will be able to solve in human-scaled feasible time, i.e. in our lifetime. Companies like Google, Microsoft and IBM, Google has already claimed in October 2019 that they have achieved quantum supremacy. I don't know what exactly they are doing with it, but I think it would cost a lot of money today, so I assume they'd be working on how to make it cheaper. But if one company cracks quantum supremacy in an affordable manner, they're in hell of a position to dominate the world, not to sort of instill fear into everybody.
So what I would say is, yes, as as you rightly say, there are definitely risks associated with quantum computing, and obviously, if a particular company or country, depending on sort of the way you look at it, it might be sort of like Russia, China, using these for uh, nefarious purposes, then then it does pose a potential risk. So what obviously, in terms of companies, and this is the thing just in general with tech companies as well. It's tricky to regulate these things, but obviously we have to try and do that. I think that's going to require, of course, some sort of global effort to actually, because some of these key things like tax evasion, when people some of these international problems, these are problems that need to be dealt with. No single country can deal with it, so it has to be a group effort, which makes it all the more difficult when you need that level of cooperation. But yes, it poses those sorts of risks, especially if you get people with ill intent getting their hands on it. But there's also a flip side too. Obviously, you can hack a system more easily, perhaps with a quantum computer. But there's a flip side in the fact that there are mechanisms by which you can potentially, instead of using classical cryptography, you can use quantum cryptography, and these are obviously systems that might be a lot more secure. How feasible it is to implement these? It's difficult to say. It might be quite tricky, of course, because quantum states are supposedly quite volatile. So having to transfer those across various distances might be a bit of a challenge. So I think those sorts of things limit quantum cryptography in a sense. But but in principle, quantum cryptography should be. It makes sense in principle. How it works practically is the more tricky aspect to it.
I guess there are current encryption techniques that would, how do I phrase this? Like, if quantum computing became a thing, they wouldn't necessarily be able to hack into or decrypt these current encryption techniques, but they're just not very widely used right now. So it would require like a massive overhaul of all of these current systems in order to make everyone's data secure and safe. But that's just, I think, asking too much to make sure that all websites, everyone who holds any personal details or data on you, everyone goes out of their way to like change how they store all of your data. I don't think that's very feasible.
Of course. I mean, there was this fact I read on the internet. I think this was in 2018, and it was that over 90% of all data created in human history was generated in 2016 to 2018 alone, which is a lot of data. And of course, in 2020, that is going to be a lot more. So for hackers, there is so much more data out there to hack, I suppose, and perhaps even with quantum computing, it might still be near to impossible to hack even a small proportion of that data, given that there is so much data out there. So I'm not exactly sure how worried we should be about our data if quantum computers become a feasible thing.
I mean, I had my Netflix hacked last year, and I got 3 emails successively. One saying someone had changed my email, one saying someone had changed my password. Oh, and the first one was saying there was a new login into my account, and that freaked me out. And after that, I changed all of my passwords and got a password manager, because up until that point, like, I had maybe like 5 or so different passwords that I would cycle through for different websites, but I didn't have a unique one for every single website. And after that, I kind of realized, okay, I kind of need to have a different one for everything. There's also, if you are worried about something like that, there's a really good resource. This is not sponsored or anything. This is just very off tangent. On ClearScore, they have a dark web monitoring service where they will check how many times your email has been listed on the dark web alongside a password, and they will tell you for like different websites and the passwords that it has been listed with. And I found my password on there, I think it was 42 times. So out of the 5 passwords I used, 4 of them had been posted somewhere. So yeah, if you do want to check that out, that's a really good service. You might want to look into that.
It's quite frightening. But yes, I think it's certainly something people should be aware of. So better safer than sorry, as they say. But still quite frightening.
Yeah, I'm definitely going to check that right after this recording. But yeah, I was going to say, for someone who's not a celebrity or a famous person, their data is going to be more safer, but it seems like these hackers just choose people at random. And of course, with quantum computing, this is going to be a lot easier. I mean, with Google having achieved quantum supremacy, I'm curious as to what is stopping them from doing naughty things with it. I mean, for all we know, they could be doing these things in secret. Or there might be another organisation out there who have sort of cracked quantum computing and are doing illegal things with it now. I mean, this is already a hot topic, depending on when you're listening to this podcast. But this week, the CEOs of Apple, Google, Amazon and Facebook are having to testify at US Congress on the matter that they are quite dominating, so much so that their influence and power is having such a negative impact in not just America, but really the whole world. But what would stop people or organisations from doing bad things with quantum computing if they have achieved quantum supremacy?
I feel like if there was someone out there who had reached quantum supremacy before Google announced it, why would they hide it? I feel like if you invest that much time and energy into something, surely you would want the world to know. It's not something that you just, I don't know, cook up in your basement in like a week. It's something that you invest years into. But that's my personal opinion.
I think it would depend upon what their intentions are with the system. If their intent is to is malicious and nefarious, then I suspect that you'll want to be subtle about that, so that people can't, so that people are less aware and less able to defend against it. I presume is what might be the motivation for that. But obviously, again, we can only speculate, as we say.
Just adding to what Alex said, I remember reading this hypothetical situation of a company creating AI that takes over the world without the world knowing it, and it's in the book I mentioned last week, Life 3.0 by Max Tegmark. Just adding to what Alex said, I remember reading this hypothetical situation of a company creating AI that takes over the world without the world knowing it, and it's in this book I mentioned last week, Life 3.0 by Max Tegmark. And I assure you, this podcast is not sponsored by his book, but it is a really good read for those kind of issues. But I'll give you a quick summary. They have this company called the Omega team, which basically builds an AI that generates money from Amazon Mechanical Turk, which basically is a crowdsourcing platform for human intelligent tasks. Computing tasks given to humans because modern day computers are relatively poor at performing these tasks, such as identifying objects in images. Anyways, it generates a bunch of money, then diversifies its income by creating video games and movies that are indistinguishable from human-made ones, making even more money, and then its world dominance sort of spirals out of control without anyone other than the Omega team knowing. So yeah, this kind of thing I believe is highly unlikely to sort of occur on this extent, but it is a possibility. But This is sort of a prevailing idea already. The idea that tech companies sort of already reign supreme power over governments. The best example I can think of is Facebook meddling in the 2016 US presidential election. If this is already happening now, then this sort of thing can happen in the future as well. Tech companies having full power over governments in their countries, and perhaps due to globalization, other countries, and quantum computing is just sort of going to help them, really.
Yeah. I suspect that whereas where we had like a Cold War in like the past and the history, where the Cold War was like a nuclear arms race, I suspect that the sort of the next sort of analog to this will be a quantum computing race or race in general computing power. So it's a thing to watch out for, and then definitely with Facebook and all the allegations over Russia meddling in democratic processes, with more advanced computing power, these things can only the potential for mayhem that could be caused by these can only get more and more.
I mean, do you think we could potentially see governments collapsing and being replaced by tech companies as a sort of leading power in a nation or even across a number of nations in the future?
I feel like they would keep governments around to have, like, I don't know, a front, but they would have all the influence behind the scenes. So maybe they don't want to go directly into politics, but they want to have all of the power and the influence behind it. So I guess, yeah, they might start. I mean, this is already quite a big thing in America, right? Like, big companies and industries have a lot of influence over different parties and stuff, and that kind of affects their politics over there. I'm not sure how much that is the case in other parts of the world, but I guess it just comes down to corruption as well. How corrupt, I guess, the government is. I don't know. It's a weird one because you can't really predict how these things are going to go until they happen, and then you suddenly realize, oh yeah, that was so obvious from the start.
I think a lot of the time they have a lot of influence already, and I think they'll try and sort of be subtle about it rather than direct if they can.
Now, putting all the doom and gloom aside, there are obviously amazing things that quantum computing will enable us to do, mainly to do with the early stages of drug research and development. For example, the modelling of molecular structure and how drugs interact with proteins. Now, I know this is going into biology, but I'm going to try my best to explain this. We have to sort of map all the combinations of the interactions between the drugs and the molecules in our bodies, and this of course will require a load of simulations. There's an example given by IBM that the number of transistors required to model the base state energy of penicillin, which is already a very well used drug, would be more than the number of atoms in the universe. So just to put some numbers to those claims, the latest iPhone has about 8.5 billion transistors, but it is estimated that there are 10 to the 78 atoms in the observable universe, which is of the order 10 quadrillion vintillion, if I've pronounced that correctly. So, I mean, you know it's a pretty big number if the suffix is used you've never heard of. And of course, quantum computing would change this entirely, since its computing power is infinitely greater, really, on our scale due to qubits. Now, of course, this is just one positive application of quantum computing, but what would you like to sort of see quantum computing being used for in the future?
I think, as you said, in modelling these sort of medicinal, well, not just medicine, but just sort of in general, helping deal with some of the world's greatest challenges. So I'm not sure what other examples we can look at, but I mean, definitely medicine for one. Um, there are probably a whole range of issues where it can also be applied wherever you need any calculations and modelling performed. Uh, but yeah, I think just that increased computing power. I mean, computers have just already done so much, so just think of that, but better. And then then you've already created some improvement in the world. Obviously, with the associated risks and keeping those in mind.
Um, I guess I might be biased as a physicist, but I guess, yeah, just being able to solve um, equations and problems that we haven't been able to before because quantum computers can just crunch through numbers so quickly, and they can go through different solutions very, very quickly. Like on a scale that we haven't been able to so far. And I guess also back to the modeling thing, again, just being able to model materials down to like an atomic level, because right now, I guess the way we think about these things, we kind of can't really do it on a microscopic level. When we're considering large systems, we kind of have to take a step back, look at it kind of macroscopically, and model them that way.
I think an interesting thought is whether a quantum computer will be developed such that we can fit one in our pockets, like we can a regular computer that, when first developed, took up the space of an entire room or even a building.
I think it depends. Certainly, like, for instance, I know, for instance, like, as things get cheaper and cheaper with time, I think it might be possible in the future. I know that liquid nitrogen, for instance, it costs like about the same as milk, I think, if I'm wrong. Or I might be wrong there, but but I think that's the rough pricing, and that's fairly like affordable for most people. Obviously, storage is going to be a problem, but you could buy some liquid nitrogen, at least. And as hope and as the process of making these sorts of things, these cooling technologies, becomes cheaper and cheaper, as one might expect in the future, then it's certainly possible. Obviously, thinking about it now, it's quite difficult to sort of imagine that, because it's obviously requires quite a few practical leaps, but it's probably, I suspect it might be possible in the future, but just obviously how soon is quite a big question.
I mean, my answer instinctively was to say, well, probably not in my lifetime. But I guess people maybe like 20, 30 years ago didn't think that we'd have computers in our pockets, like smartphones. So I guess, yeah, it just depends on how quickly all of this stuff progresses. And maybe in the future we'll find out that, I don't know, quantum computing isn't a viable option when you want to have it like on smaller scales, so for people's phones or laptops. And maybe its only use will just be in these big supercomputer type things. So who knows?
So, just to give you some facts, computing gets half as expensive every 2 years. So, the computing cost of a given operation has gotten 10 to the 18, or a million times cheaper than around 80 years ago. Now, this is all, of course, in the far or even near future. We just don't know. But to reach that level, there are, of course, many challenges in quantum computing that we have to overcome. Now, I know you know about some of these challenges, Aisha, right?
I read this thing about decoherence.
Yeah, that sounds complicated.
Yeah, I have absolutely no idea what it means. Would you care to explain it to us, please?
Oh, yeah, I mean, I read something about it that I understood. Whether or not that's right, no. So Decoherence makes quantum computing much more error prone compared to normal computers, because the subatomic particles themselves can interact with their environment. So if there's a change in temperature or if there are any vibrations or anything, and it can change or alter the state of that subatomic particle and cause its like quantum behavior to either decay or disappear completely. And so from what I read online, for like every qubit you have to have multiple in order to account for the fact that some of them might be altered. I think currently the way they do it is they have like these computers inside like super cooled fridges or freezers and inside vacuums to try and minimize these effects, but that's not really something that would be feasible for people in their daily lives if this was to become much more mainstream. So that would have to be something that's like looked into, or if it has been looked into, then I don't know, I haven't read that far into it, but yeah.
I think, as Aisha rightly pointed out, microsizing these sort of cooling mechanisms is actually probably going to be quite the challenge. So obviously that might be the biggest. I think that's probably the biggest hurdle towards personalizing it. So like so that you have like personal quantum computers, if that is at all possible.
Now, there are of course good and bad applications out there, but we have to kind of make sure that the bad stuff doesn't overweigh the good stuff. And this can mainly be through education and awareness, or through policy making and regulations, for example. Do you guys have any other thoughts on how we can overcome issues like this?
I don't think that's something you can control. As in, it's something you can try to control, but it's inevitably going to be there, just like normal computing is as well. So, yeah, I guess it's difficult to say because, I don't know, you could have governments try and implement policies and make laws about all of these things, but inevitably you're going to find some people who find a way to bypass the system and use computing power however they want, really.
I think that's completely right, essentially. Insofar as we can control it, we should try and restrict and limit the potential harm that can be done. But as we're seeing, I mean, we're struggling right now to limit the harm that tech companies can do with normal computing. Social media, for instance, we're finding it a pain to actually sort of get them to clean up their acts and regulate them, which is just not feasible to prevent any harm. And even if you do impose these restrictions, there are always going to be people who don't abide by them at the end of the day. So yes, I think I completely agree.
I totally agree. The thing is, if we think about these issues now and sort of plan for it, then we can make sure that we're well prepared for potential issues we might face in the future. And this is something that is interesting to think about, like a sort of doomsday prep. I hope that I haven't scared you guys or anything. But that's all we have time for today, and we hope you guys find this topic interesting. And like we have reiterated in our previous episode, if we've said anything wrong technical wise, then please forgive us. But really, as Richard Feynman once said, I think I can safely say that nobody understands quantum mechanics. And everything we've just discussed today is purely our opinions. So thank you for joining us again today, Alex.
You're welcome.
And thank you to Aisha as well.
Thanks for having me here.
And I'll link my sources and references in the description so you don't sue me. And I'll include some interesting videos, books, articles about this if you want to read more.